Hi mathematicians! In this lesson we are going to practice plotting ratios from tables. A ratio table is simply a table of equivalent ratios. And we've seen these equivalent ratios in tape diagrams, on double number lines. Well, the tables are very similar to these. The equivalent ratios can be made by multiplying or by adding. The same process as we've been using before. So in the example you see in front of you, we are talking about an ice cream recipe where the ratio of sugar to cream is 2 to 3. So we can set up a table where one row represents the sugar quantities, one row represents the cream quantities. And then we start with the simplified ratio of 2 to 3. So you see the 2 to 3. If we're going to use addition, that means we are going to basically add the simplified ratio to itself over and over and over. So we'll start with 2/3, and for the sugar we'll add 2 parts, so we're going to 4. And then we're going to add, at that time we're going to add 3 parts of cream. So we wind up with a ratio of 4 to 6, which is still equivalent to 2 to 3. We can add another 2 cups of sugar, or 2 parts of sugar, and another 3 parts of the cream to get 6 to 9. And we can just do that as many times as we want, as long as we are adding the ratio to itself. We always have to add 2 parts of sugar when we add 3 parts of cream. If we're going to use multiplication, then we're going to take the original ratio and then multiply it by 2, multiply it by 3, multiply it by 4, and this will give us the same result as the repeated addition. It's just a matter of whether you prefer the addition or the multiplication. The only difference is in what we use to multiply both of them. Remember, when we added the ratio back to itself. So we added the 2 to the 2 for the sugar, 3's over and over for the cream. If we're multiplying, we're going to use the same factor for both parts of the ratio. So in the example on the screen, you see a ratio of hours to kilometers being 1 to 8. So the first row represents hours, the second row represents kilometers. We have the original ratio, and then when we double that, when we multiply both parts by 2, we go from 1 to 8 to 2 to 16. We can then multiply that original ratio by 3 over 3 to get 3/24, and so forth and so on. We can multiply the 1 over 8 by 4/4 to get 4/32, and we can keep going as long as we want to on this table. So just make careful note that if you're multiplying, you're using the same factor for both parts of the ratio, where when you're adding, you are adding the specific parts over and over. All right, let's do a little bit of practice with this. Let's use the information we see in the table to complete how many bowls we have if we have 180, 240, and 300 pieces of candy. So you'll notice if we have 60 pieces of candy, we have 2 bowls. And I like to use the multiplication. It's a little faster, a little more efficient. And so we can look and see that to get to 120, I would have to do 60 times 2. Try that again. Ooh, let's try that again. That was not pretty, was it? Okay. We had 60 times 2 here, and that works for the number of bowls also, because 2 times 2 is 4. Now 180 happens when we multiply 60 times 3. Well, that means we'd have to multiply the number of bowls, or 2 times 3, to get 6. And I know that 60 times 4 gives me 240, so all I need to do is multiply my 2 bowls by 4 to find out that I would need 8 bowls to hold the candy. And then in that last column, I know that 60 times 5 is 300, so I would have to multiply 2 times 5 to find out that I need 10 bowls. We can even take this one step further and use our ratio table to plot the relationship on the coordinate plane. The coordinate plane is defined by the x-axis, which is always the horizontal axis. It's always this one down here. And the y-axis, which is always the vertical. So we always talk about the x-axis first and then the y-axis. In the table, we are looking at the number of eyes compared to the number of noses that a cat has. and most cats have 2 eyes and 1 nose. So we're going to plot this relationship. So we'll start with the top row is always the x-axis. The second row is always represented on the y-axis. So you see over here we have the number of eyes and the number of ears here. So we can plot by taking our 2 to 1. 2 eyes compared to 1 ear, and plot that point. That represents our 2 to 1. And then we can plot the 4. We know that if we've multiplied by 2 on the x, we have to multiply by 2 on the y. So if we have 4 eyes, we're going to see 2 noses, which means we have 2 cats. Alright, so now let's take a ratio table and practice the plotting. We're going to look at the number of pens in per packages. So remember, the first row is going to be the x-axis. The second will be the y. So let's go ahead and label these. Remember, this is x, vertical is y. And let's label pens on the x-axis. Let's put packages on the y. Always label your graph so it's easy for another mathematician to understand. The next thing we need to think about is the scale. How are we going to skip count on our graph to make it easy to understand? Our pens are jumping by 2 every time. 2, 4, 6, 8, 10. If we look at our graph, we have 10 lines. So I can go ahead, I can always start the y-axis at 0. We can go ahead and just label these single count. On the y-axis, our packages are increasing by 1 every time. So we can go ahead and just do the same thing. We have 0, always start at 0. The axis is always 0. And 1, 2, 3, all the way up to 10. Alright, we'll plot the x first. We see that if we have 2 pens, that's 1 package. So we'll come over on the x-axis to 2, and then up 1, and that's our first point. Then you see that if we have 4 pens, we have 2 packages. 6 pens means we have 3 packages. 8 pens, we're buying 4 packages, and 10, 5. Okay. So then we can connect these starting at 0, 0. Always use a ruler when you're graphing so you have a nice neat line. And we can see that representation both in the table now and on the graph. Alright, pause the video for a moment and you try this graphing. Remember to label your x and y axis and to think about your scales on both of those as well. And then do your plotting. Remember to use a ruler. Okay, let's see how you did. Remember, the first row is the x-axis, so the candy will be represented here. Y is the second row, so this will be the number of bags. Scale becomes important. Now in this case, candy is being counted by tens, and we only have 10 lines, and if we did count by ones, this would be a huge graph. So let's go ahead and count by tens. Every row is going to represent 10. Now in order to keep my scale from getting squished up and hard to read, I'm not going to write every label, but I'm going to carefully skip count and label every other line. So I'm going 0, the first line would be 10, the second line is 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so now your scale is still nice and clean. You've got equal intervals or equal spacing in your counting. It's perfectly fine to do. Bags, however, are counting by ones, so let's just use that on our y-axis. And then let's do a little bit of plotting. For every 10 bags of every 10 candies, we have 1 bag. 20 is 2, 30, 3, 40, 4, 50, 5. The nice thing about graphing is, while we only have 5 pair of data in a table, we can plot those and then continue the line and predict what will happen with larger bags or larger numbers of candy. Okay, so that's what your graph should look like. Before you wind up your work today, make sure your graphs match what you see on the videos. Don't forget to do your WSQs, and I'll see you in class.